Okay. So,
Co řekne anglický krléž?
asi stejně. So, ladies and gentlemen, we shall start the last panel on the first day of the conference. So, please welcome the first speaker of the last panel, which is Dr. Nicola Scafetta. Nicola Scafetta is astronomer, and nowadays he's affiliated with the University of Napoli, Federico II in Napoli. His research interests are in theoretical and applied statistics and nonlinear models of complex processes. His paper, Impacts and Risks of Realistic Global Warming Projections for the 21st Century, surely will give us all a lot of food for thought. So please, Dr. Scafetta, the floor is yours.
I would like to talk about this topic and impact and risk of realistic global warming projections for the 21st century. And my research has been published in these two papers, at least, very recently. And so Geoscience Frontiers is one top journal. Okay, so. And we will discuss about, the topic will be how much will the Earth warm? So that is what everybody would like to know. First of all, I need to just say 1 second. We need to be careful to not confuse climate change with weather condition. Okay, so usually people, in particular in the media, show these images of this weather situation, and they claim that it's a climate change. In reality, this is not what climate is. Okay, so the climate changes very, very little in time. So this is what happened to the Earth in the last 170 years, since 1850, and this is the global warming registered by several groups, as you see here. And what we see here is that the Earth warmed by about 1 degree Celsius, a little bit more than 1 degree Celsius. But the issue is whether or not this warming has been due to natural phenomena or by human activity and so on. So we need to understand the physics behind this signal that we receive. And how to do this? Now, there are two different ways to analyze a natural signal. One way is to use climate models. Climate models essentially are creations by humans, by researchers, and they are programs that run in computers. So these programs try to simulate the climate system. In general, the climate models that today are available assume that the climate system is driven by a number of radiative forcings, which are listed here, including, for example, carbon dioxide, other greenhouse, well-mixed greenhouse gases, ozone, stratospheric water vapor, albedo, and so on, aerosol, and so on. And then there are also natural forcings, such as solar and volcano forcing. And so this model claims that climate change is due to the change in this radiative forcing. These are the radiative forcing functions that are used in the climate models. And what we see here is that according to this model reconstruction, the solar contribution is negligible compared to the change in the anthropogenic forcing. Therefore, the conclusion of these models is that nearly 100% of the forcing is man-made, And the climate models attempt to interpret the climate change using, for example, this picture, where the models are run in two different ways. In one way, like that represented here, the climate models use only the so-called natural forcing, which are solar and volcanic forcing. And they show that natural forcing by alone do not produce any warming at all in the last 170 years. On the contrary, when the anthropogenic forcing is added, then the models produce the warming. From these, the climate models claim that 100% of the warming is due to human emission. However, this interpretation of the climate models has a serious problem, because according to the scientific philosophy, okay, and so we needed to compare the models with the data to validate the model. And unfortunately, we do not have the data for the second case, for this case. So practically, we do not have the data when human activity does not exist. And therefore, therefore, this prediction of the models cannot be validated. And therefore, the models cannot be validated. So the interpretation of the climate models cannot be validated, because we do not have data to demonstrate that without human activity, the climate would have been constant during the last 170 years. In any case, this climate model interpretation is is used at all, despite the fact that it is not validated, scientifically validated, to do, for example, to do prediction about the future climate change. So what people do, for example, the IPCC, is to run the same models for the future by using different social-economic scenario. So they produce different set of predictions according to the emissions that could happen in the future, and then they claim that they compare these predictions with this kind of chart here, which are the vulnerability charts, where essentially it is claimed that if the temperature goes above 2 Celsius relative to 0, which 0 is the pre-industrial temperature, so the temperature between 1900. So if the global warming crosses this line, this 2 Celsius line, then there will be problems in several sectors. Okay, so water security, coastal community, natural ecosystem. So and therefore, Paris Agreement claims that we need essentially to remain below the 2 Celsius, But the 2 Celsius means to remain below the 2 Celsius. There is the need to satisfy the SSP1 socioeconomic scenario, which is the zero net emission by 2050. Any other scenario, any other possibility will cause a global warming crossing the 2 Celsius. So we will not be able to adapt according to these models. But of course, no country in the world is following the net zero emission scenario. Although and therefore we need to do more according to this situation. And the Europe is very active on this interpretation, because of course Europe is trying to force this carbon net zero by 2050 to try to save the world. The problem is, however, these policies are very expensive, so people are very scared about this policy. The problem is, however, whether or not the alarmist narrative is based on sand or rocks. So let us discuss a little bit the critical issues regarding the climate change. So practically, there are three main issues here. First of all, we need to identify a realistic shared socioeconomic pathway, because according to different scenarios, pathways, the prediction will differ a lot. Okay, will differ a lot. These are the prediction of the models. Then we need to identify how much the climate is really sensitive to increase of greenhouse gases. Finally, we need to determine whether or not the climate models are really reliable. Okay, so there are a lot of issues here. So let us discuss the first issue: which shared socioeconomic pathway is realistic for the future? Now, there is this paper on Nature who claims that the most realistic scenario for the future will be the will be this one, that is the SSP2, which is not a net zero scenario. The net zero scenario is this one, the SSP1 by 2050, and this scenario is not realistic, okay, according to economists and so on. So we need to argue with this scenario that is probably the only one that can be achieved, realistically achieved by the world. Nevertheless, the IPCC adopts a lot the SSP5 scenario for proposing its policy. Okay. Nevertheless, the SSP5 is not realistic at all. The SSP5 would be this one. That is the worst one, but it's not realistic at all. Okay. So we need to use the SSP2. Then, which models could be realistic? So the problem is here to discuss the equilibrium climate sensitivity issue. Now, the problem is that, as I said before, the climate models are not validated and cannot be validated. So what happened here is that a lot of people in the world have proposed different climate models. These models are very, very different. These are some of the models. These numbers that are here are called the equilibrium climate sensitivity, and that is the global surface warming achieved at equilibrium after doubling the atmospheric CO2. And according to these models, for example, doubling CO2 means to get a 1.8 Celsius degree. But according to these other models, the climate sensitivity is 5.6. This means that there is a huge uncertainty regarding the real climate sensitivity of the model. So there is the need to reduce this gap. And people are realizing that there is a kind of hot hot model problem. So the models are running too hot. In particular, in this chart, there is an estimate of the climate sensitivity according to the IPCC. So in the literature, the climate sensitivity may vary between 1 and practically between 1 and 6. The IPCC suggests this window, but a number of studies, recent study, claims that the climate sensitivity might be relatively low. For example, these are three: Lewis, Scafetta, Spencer and Christie, and others have suggested very low climate sensitivity. And this is the demonstration that the climate sensitivity should be low because the climate models are running too hot. So, for example, if I use the climate models with a high climate sensitivity, they are clearly running too hot. The medium climate sensitivity are still running too hot. Only the low climate sensitivity models seems to be catching the data. Nevertheless, there is a problem here because if we use the satellite data, the climate sensitivity might be much lower, and all models would be wrong. The third issue is whether or not the climate models are physically correct, because they may be incorrect. As I told before, the models cannot be validated. So now here there are several problems because the climate models, this is a picture of the IPCC, show that the climate models are running too hot in many places. So, for example, this is the temperature of the troposphere, the trend of the temperature of the troposphere. And what we see here is that the models, these are the models, predict a warming much greater than what observed in the atmosphere. There are problems regarding the surface temperature. The surface temperature may be biased by urban heat island. There are studies who show that probably the global warming is biased. It's a little bit biased by 20–30%. So the real global warming should have been lower, as the satellite records show. So, for example, the satellite records here show that on the sea, on the ocean, they agree with the temperature recorded at the surface, but on the land, the satellite records, which are in blue, show much less warming than the surface. So this difference may be due to urban heat island that has remained inside the record. And if we, for example, we reconstruct the global warming using only the rural stations, then it's evident that the warming is much less than what suggested currently by the records, the climate records. Okay, so there may be climate records may be wrong. There is other problem regarding the models. For example, here we have that during the Middle Age, this is another picture from the IPCC. During the Middle Age, the climate models, which are in red, are not able to reproduce the warming, the medieval warm period, are not able to reproduce the warming during the Middle Age, which means that the models are not able to reproduce the warming period of the past, which suggests that also during the last century, the model may be missing some very important mechanism, the physical mechanism. Okay, so this picture that is published by the IPCC actually demonstrates that the models are wrong. They are missing very important physical mechanisms. This is one of my papers where I show that the same thing. So in the Middle Age, the models are not able to reproduce the warming. So they are missing important mechanism. The Middle Age was warm. There are a lot of evidence that the Middle Age was warm. For example, on the Alps, it's possible to find a lot of trees or wood in places where today there are glaciers. So that means that in the past, the Alps were significantly warmer than today. And what is missing in the model? Very likely, the models are missing the real effect of the solar activity on the climate. We have a huge amount of papers, empirical papers, suggesting that the sun is the main driver of of climate change. So these are some of correlation, some papers that show this correlation. This is another paper that show a strong correlation between solar activity and the flood frequency in the Central Europe. So the correlation is extremely high. So this suggests that solar activity is very important in driving climate change. But the problem is that the models are using probably wrong solar irradiance forcing and also do not understand how sun actually acts on the climate. So for example, solar activity is total solar irradiance is uncertain. So solar physicists do not know exactly what happened to the sun, what the sun did, but the climate modelers are using on this record, this pink record, this purple record for interpreting solar activity. And this record is just one of the records proposed in the literature, and it is the one that changes less. So practically, the climate modelers are assuming that the sun solar activity does not change in time, and therefore they claim that the sun does not affect the climate change. So, but that is a choice that is not justified by science, because science is uncertain on this topic. The problem is that if we consider different kind of solar forcing, these are some proposals, and we assume that the climate may be affected by the sun by other mechanisms, so for example, cosmic ray effects, or in any case, alternative effects. What we find is we can find some very interesting results. So practically here we have, this is the typical simulation of the models. So we have here the solar activity practically does not change at all, but if we use alternative solar forcing, the solar activity may be much bigger, the solar effect on the climate may be much bigger, and the anthropogenic forcing effect would be much lower. So we have this alternative interpretation, and this is the model. This is the model interpretation. This is the same interpretation of the same data by using the different kind of solar forcing and the solar mechanism, which claims essentially that about 50% of the warming is due to the sun, and maybe even more than that. But this interpretation seems to be better because the models actually interpret correctly the modulation that we observe in the climate system. So the models may be missing the real solar effect on the climate, which means that the climate sensitivity is even less than what the low sensitivity models claim. So, in conclusion, we have these three considerations. So we have that the climate sensitivity must be low. There may be some urban heat contamination, so we need to use satellite records. And then there is a problem of natural solar variability that is missing in the climate model simulation. By using these three hypotheses, it's possible to re-estimate the risk for the future. This is in this case, we use only the low sensitivity models. Here we use the satellite records. So we rescale the model on the satellite records. And this is the simulation with the natural modulation of the climate system. So by introducing the solar effect that is missing. So we see here that the future, the climate will likely be below 2 Celsius, which means, and this will be obtained using the SSP2 social economical pathway. So which means that we do not need the net zero emission scenario, which is the SSP1. So practically, these are the simulation, the prediction from the models that are used by the IPCC to justify the alarm. because essentially this simulation claims that only the net zero emission scenario will save the world because the temperature will remain below 2 Celsius. But by taking into account all I have shown to you, it is possible to demonstrate that also the SSP2 pathway, which is a moderate pathway that does not require a net zero emission scenario, also in this case, it's possible to achieve the Paris Agreement. Therefore, there is no alarm. There is no alarm. Climate alarmism is not justified. We can use some moderate pathway to achieve the same goal, and therefore to keep safe. Okay, to keep safe. So in conclusion, this is okay. There are some economical issues that I don't know if I have time, but so I would like to stop here because essentially the models are not validated. They cannot be validated. There is a huge uncertainty in the models. They are missing a very important solar mechanism, which appears to be very, very important. And essentially, if we take into account all this uncertainty, the end is that, in my opinion, climate alarmism is not justified. So the policy used by the suggested by the European community are not really justified by science. Okay, so it is according to this situation. Okay, so I finish here.
So thank you very much. And now there will be a short time for comments or questions. Are there any comments or questions? Okay. So if not, I will have one. Dr. Scafetta, would you be so kind and describe more detailed the models you mentioned, and who is the author of those models, who created them? Thank you.
So I have shown you two things. So one are the models used by the IPCC. So those models are created by many groups around the world. Then the results that I show you, the final results that I show you are models which are published in my papers that I show at the beginning. I show at the beginning of the presentation, which are essentially these in these two papers. In these two papers that are here, there are the models that I show you. So you need to take these two papers. And here it is, everything is detailed. I would like to stress that this journal, Geophysical Frontiers, is one of the top journals in science, so in this field. So they are very important papers, in my opinion. So eventually you need to look at these two papers, and you will have all literature and all arguments, and the models are detailed and so on. Okay.
I've got a brief question. Professor, can you hear me?
Yeah.
Can you just very briefly summarize which are the biggest shortcomings of these models? Is it lack of taking into consideration the solar activities, or is it the negligence or bad tackling of the feedback mechanism, the positive feedback? Which is the biggest shortcomings of the models?
Now, there are many shortcomings in the models. There are many. So very likely the problem is the feedback, as I show you here, the feedbacks.
So right now, I'm muted. All right.
And your camera is also closed, right?
Okay, the feedback, do you hear me? So the problem of the feedback is that is implicit in this picture. So the models do not know how to model the feedbacks, okay? do not know how to model feedback because they have all different feedbacks. And that is the reason why these numbers are so different from each other. So the feedbacks are not correctly modeled. Then there is the problem is that the models use a solar forcing, which is this one, which is what is that one? This solar forcing that is practically flat. But in the literature, there are many different records around the solar models. Then the models do not have mechanism other than a total solar force, total solar irradiance forcing. So, for example, if the sun is influencing the climate system via magnetic activity, for example, cosmic rays, then which acts directly on the cloud system, then the models are completely missing the real mechanism that control the climate system, because very likely the climate system is controlled by the cloud system, okay? So much more than total solar irradiance alone, okay? And the models do not have those mechanisms. Finally, the models are assuming that the global warming is given by this kind of curve, but this curve very likely is biased, is warm biased, because these records, this curve has a lot of urban heat inside it. Okay, so urban heat is not the climate change. So they are exceeding it. So the models are a lot of problems, and the evidence that the models are wrong is given, for example, by this picture from the IPCC, which is the troposphere warming, that the models are too warm compared to the data. And then there is this other picture, always from the IPCC, that show that the models do not get the medieval warm period. And therefore, the models are clearly demonstrated wrong by the IPCC itself. This is a picture from the IPCC, where they say clearly that there is some big problem in the models, because the models essentially, it claims that the climate is always constant. Okay, the red curves say that climate is always constant, but of course, in the past, the climate have changed a lot, and there were many periods, warm periods in the past. Okay.
Yeah, thank you. Very good. Very good. Thank you.